This is a continuation of topic 28, special right triangles. In the previous video, we defined the 45, 45, 90 triangle and 30, 60, 90 triangle. 45, 45, 90 having side lengths 1, 1, and root 2, and 30, 60, 90 having side lengths 1, 2, and root 3, 2 being the hypotenuse. We defined the three trig functions for each angle, and we did an example problem where we helped use these special right triangles to create a set of two similar triangles and therefore set up a proportion and solve for missing sides. We're going to continue doing that here in practice problem number 1. So the overall goal of this is I recognize that I have a 30, 60, 90 triangle, and I can create a similar right triangle to it. This is the special 30, 60, 90 triangle drawn in the same orientation, 30, 60, and 90. These triangles are similar, so therefore I can set up proportions to help me find the missing sides. We will set up two proportions, one for x and one for y. The only side length that has the number on both is this 7, so the side across from the 30, and this 1, side across from the 30. So we'll create 7 over 1 in both triangles. We now are going to go ahead and set up the ratio, relate the sides that are unknown. So x matches up with the side length of 2, x over 2. And y matches up with side length root 3, y over root 3. I've now created a proportion that I can cross multiply and solve. X times 1 is x, 2 times 7 is 14, x is equal to 14. 7 times root 3 is just 7 root 3, and we've found our missing values. Next question, we'll go ahead and do this. Once again, we have two unknown sides. We are giving one angle and one actual side length. I do recognize that this is a 30, 60, 90 triangle, so I will draw a similar triangle to it. 30, 60, 90 triangle in the same orientation, 1, 2, root 3. I can now set up a proportion between my unknown sides and my known sides. The only side that matches up is 1 and square root of 6 in terms of they both have numbers, so square root of 6 over 1, square root of 6 over 1. We're now going to pair up our unknown sides. Y pairs up with root 3, y square root of 3. And our unknown value of x pairs up with 2, x over 2. We can go ahead now and cross multiply to simplify. And y times 1 is y, root 6 times root 3 is actually root 18. We can simplify this further as 3 square root of 2. We do this by recognizing 9 times 2 is the same as 18. The square root of 9 times the square root of 2. Taking the square root of the perfect square gives me 3, and we leave a root 2. For my other value of x, 2 times square root of x, we can't multiply those together, so we just leave it as 2 times the square root of x. Both of these problems, again, were drawn from the same 30, 60, 90 triangle. We just drew it in the same orientation and created similar triangles, set up a proportion to help us solve. Let's go ahead and do two that are 45, 45, 90. So this problem here, we can set up a similar triangle due to the fact that we have a 45, 45, 90 triangle. This is 90. We have 90 left over. 45 minus 40, 90 minus 45 is 45. And we have the triangle 45, 45, 90, 1, 1, root 2. Once again, we have two similar triangles, so we can set up two proportions. Our known values in this triangle are 7, root 2, and root 2. Those are the numbers that match up. So 7 root 2 over 2, 7 root 2 over 2. And we'll pair up our unknown sides. We'll start with x. X pairs up with 1. And then finally we have y pairing up with 1 as well. We will cross multiply to help us solve here. 2 times x is 2x. 7 root 2 times 1 is 7 root 2. We would divide both sides by 2, giving us x is equal to 7 root 2 over 2. I can't divide the 2 underneath the square root and one that's outside. I would only look to divide the 7 and the 2. If this was an 8 over 2, we would make it 4. If it was 12 over 2, we'd make it 6. If it was 100 over 2, we'd make it 50. But we cannot actually simplify that down, so here is my answer. Same process over here. We'll divide by 2, giving us y is equal to 7 root 2 over 2 as my exact answer. Again, similar triangles, setting up a proportion, helping us solve for the missing side. This one as well, we're going to go ahead and create a similar triangle between them. 45, 45, 90, side lengths 1, 1, root 2. We can again set up a proportion, two proportions to help us solve. We have 12 over 1, 12 over 1, as those are the two side lengths we're known. We can set up x with root 2, and y can be set up with 1. Cross multiply and we get x is equal to 12 root 2 and y is equal to 12, those being my answers that are simplified down. There is a Khan Academy online assigned to you regarding this special right triangles. The process of solving special right triangles and solving two similar triangles, the process is actually very, very similar in the sense that it's the same process. It is, in fact, the same process each time. We're creating two similar triangles and setting up a proportion. This is a lot easier to do. Thank you very much. Memorize these two right triangles.